Rail Up, the Future Mobility podcast with innovators and leaders of the ecosystem. Presented by Sebastian Sperker.
My guest today is Eyal Trichter, the CEO of Trilogical Technologies, a tech company based in Israel that specialized in cutting-edge solutions for the railway industry. We will be discussing global innovation in the railway sector with a special focus on the virtual digital coupling, a promising new approach with transformative potential. We will also dive into the critical issue of cybersecurity and what it takes to hack a wagon or a locomotive. So let's get started and welcome Eyal, live from Israel. Hi Eyal and welcome to Rail Up the podcast. Eyal, are you an innovator or a leader?
Hi, Sebastian. First, I would like to thank you for inviting me to this amazing podcast. As for your question, I see myself primarily as an innovator. It's constantly looking for ways to challenge the status quo, with bring new ideas with, I would say, clear, different differential values. I find great satisfaction in taking challenges, diving into detail, because all the engineers know that the devil is in the details, you know?
Absolutely. Yeah.
And thinking about how things can be done differently and better, this is what brings me energy, and this is what makes me happy each time I'm coming to the office. And I believe that this is the most thing that motivates me to be creative and to create a new developments for things that I found very critical and important for the global, I would say, global transportation or global benefits that I believe with.
Okay, thank you very much. Yeah, then let's start. And today we're diving into the topic of the digital automatic coupling again, but from a completely different angle. And the time we will focus on the virtual digital coupling, which aims to address the challenges currently faced by the DAC. And the company behind this innovation solution is Trilogical and led by the CEO Eyal. So that's you. And first of all, can you give us, to get a better understanding of where the solution comes originally from, could you just provide us a brief overview about your company?
Yeah, sure. Trilogical was established at 1994, long time ago, much before we started to work with the railway only. We started with fleet management, we started with the defense, like some of the Israelis company. We also continue with the logistics. And as often a way of life, we recognize an opportunity, and we found myself answering a tender, attending one of the strategical tender that we believe could be a game changer for Trilogical. Eventually, we won that tender, a successful deployment, a great team, new opportunities that took us to a new innovations in that specific project. Actually shift most of our activities into this area. I must say that just before the COVID, we invested a lot of our engineers and resources with the aviation, but again, the COVID shift those resources back to the train, and including with some of the other opportunities that we found through the way, we found ourselves very deeply in the railway technology. And since 2008, we actually continuously developed new integration, new digitalizations and modules to understand better what is happening inside the train, to understand better about the operation and the maintenance procedures, and to connect the dots in order to improve the efficiency both of the maintenance, operation, and safety.
Okay, so basically there are three, like say, divisions of your company, right? So aviation, defense, and rail. And today, of course, we will talk about rail, but I find it quite interesting because, like, also in my previous podcast with Ares and also others, are like some of the people's really, or some of the innovation really come also from the defense. Yeah, so as a starting point, and actually the internet started back then in the US, actually from defense or military purpose. We're talking about the people behind it. How comes that you're working in the rail tech company or in the Trilogical? So give you a little bit background of you, please.
I myself, a technical guy. I've been a technical with my studies, with the service in the military, and through the years before Trilogical, I've been project manager. Before that, a developer in one of the biggest software companies in Israel. After that, I started in the army as a technician or as an engineer for advanced communications, and then I moved to the civilian market as a developer, project manager, VP for R&D in one of those startups at the beginning of the 20s. And after that, I went into Trilogical. And as I said, we were very deeply in the technology of IoT communication, edge computing, how to make the operation more efficient and other behaviors. And the tender and other opportunities just took us into the railway sectors. And at that time, I've been the VP for R&D in Trilogical, so I had a full responsibility about everything.
And can you also tell me how you come to the ecosystem of rail and Trilogical and to join the industry?
Sure. At the time that Trilogical won the tender, I was the VP for R&D, and for all that time I was in the details, and I was fully in the railway development, and this is how I reached there.
Okay.
And I found that very attractive, both on the technical and the operation side, and this is how I actually joined the contribution and the efforts to push the railway industry forwards from my end.
Okay, that's really nice to hear. Like you have aviation, defense. You might can think about that's a super exciting one, but if you like more the railway, it's even better.
Yes, I am.
Yeah, and basically, can you also what was, as you have these three divisions, like what was the most adventurous project in rail so far for Trilogical?
I think that if I would look back a few years ago, we won a very challenging strategic tender in Thailand.
Okay, wow.
Yeah, and it was quite amazing about how technical it was. And after looking about all the requirements, we seen that it's very challenge, but we couldn't understand how much it challenge, because one of the small paragraph asked us to monitor a new CRC Chinese locomotive.
Okay, yeah.
In the very deep understanding of what is happening there. So when we came to the project, after winning the project, it's include 175 freight locomotives. 20 of them were those Chinese one. And we've been asked to monitor at the beginning only 5 or 6 signals, but there was a very small sentence asked us to provide also information of what the driver see.
So what the driver sees, so basically the camera view of the driver.
This is one translation, okay?
Yeah.
The other translation is just to have all the information the driver has and to follow that to the control center. In order to do that, we were asked to analyze 100% of the traffic being moved or being served inside the train and send it to the control center.
Okay.
So from 6-7 signals, we face the challenge of reading the entire protocol of what is happening in the Chinese locomotives without having any preliminary information about the network, about the architecture, about the protocol itself.
Yeah.
So we took those challenges in our two hands, and we went into the protocol. We successfully analyzed 99.5% of the entire information. And not with the camera. We just duplicate the entire driver HMI or HDMI in the control center in a latency of few seconds only, without having any piece of information from the Chinese about how to do that. So it was all self-learning of the protocol, how to translate that, how to send that, and I'm glad to say that
You succeed.
the end customer was amazed
Okay.
from that kind of achievement. Together with that, we had a lot of achievement through the years, starting with analyzing information on the signaling, again, without getting the protocol themselves, analyzing information on the new Alstom's trucks locomotive, and very interesting project we had in Africa. So they changed the way they operate from Excel sheets and paper into digitalization. They reduce amount of teeth. They increase the operation efficiency by 20%. All of those milestones, it's quite amazing about the amount of advantages that we had through this period in the rail project.
Cool. I mean, I really like the global approach, and also the podcast is a global one, so that is great. But now let's talk about your solution, because this is where we started our common journey. Because you said, like, because there's the digital automatic coupling, and you just put a V in front for the virtual digital automatic coupling, and I was really excited about this approach. So can you tell us something about these solutions?
It started with digitalization, as you mentioned. Our aim was to streamline the railway operation, to empower the operators with information that we made as a fusion between assets, sensors, and information from the operation, just to minimize downtime in operation and to increase the reliability.
Yeah. So that's the story of the duck, more or less.
Yeah, in one way, but I'm talking now mostly on the Control Freak, which is our brand name for the remote monitoring. Something like 5 years ago, I've been introduced with the modernization of freight trains and the requirements for the automatic coupling that was raised as a subject, as a topic in the Shift to Rail conferences. It was between 2019 to 2021, and it became a focus in the R&D agenda. So even then, it was very clear to me that as it's very necessary, that the transition could be very highly complex and extremely costly. At the time, there were some few projects that tried to establish wireless connectivity just to have this gap in years and requirements and cost, but none of them successfully transfer into commercial visibility because eventually the challenges were energy consumption, reliability, and the cost itself. And that was the time when I decided to start and begin with the developing of reliable solution that was specially designed to be scalable, to consume very low energy, and to be very reliable, to enable mesh connectivity between freight wagons and the locomotive. And I'm very glad to say that today, most of the challenges, it's never all of them, are already behind us. And today we're enabling not only a connectivity, but also train composition data, wagons health monitoring through vibration and external sensors, and end of train alerts.
Yeah, to sum it up in my words, you equip every wagon with a device which consists of a transmitting unit, sensors, and a battery pack. And these devices are communicating via the mesh technology. So all the wagons are kind of interconnected, and all these data were then sent wireless to the device in the loco. And as we don't have energy supply on the wagon, you find a good balance between energy consumption and battery size, and that with a low cost tag. So is that what you and your device is doing in simple words?
Yeah, it's correct. It needs to be very cost sensitive. And when I say that it needs to be reliable, we cannot trust or we cannot ensure that that kind of device will be on each and every wagon.
Okay.
There could be cases that some of them will not be equipped with our devices. There could be a case in which the battery will go off in one of them, let's say. So when I'm saying reliable, we also had to and to be able to, I would say, jump or to cover a few wagons that do not have that kind of technology embedded. And it needs to be reliable in a way that it continuously keep the network alive, even though it's moving in some challenging area or near a lot of rail cars and metals area. So yes, the challenges was to make it reliable, not to be sensitive to cases in which one of those devices is not installed or is not working. And automatically, and this is again, when you're sitting at home, usually you need to go to the Wi-Fi and set up the connectivity in the mesh. We are doing that automatically because we cannot ensure that the same wagons will be connected to the locomotive. Eventually, everything needs to be automatically reliable, scalable to kilometers, and be able and deliver the features that are necessary for the operation.
And the reliable, like in terms of like as your company or coming from defense, I think it's another level of what is reliable or should be. And but can you just also explain it, because a colleague, because when I started to talk about the virtual digital coupling, one colleague just asked me, you need to ask Eyal following question, like how you ensure the integrity of the train. Because one of the biggest parts of the DAC is basically that you have automatically with the last wagon the integrity that you know, okay, the train is, I don't know, 25 wagons long and that's the last one. So, and if we move, all of the rail cars are moving with the train. So it's safe, no wagon behind. So how you solve this problem to really have all train cars to know what is the last one and that they're moving?
Great question, very technical one. Part of the solution first is automatically to analyze the composition of the train. Based on the information we get from the network, we know to analyze what is the last car or what are the 4 last cars. And as the train starts to move, we immediately create that kind of a network. We analyze the last cars in the composite, and we continuously sending acknowledge messages to the end of the cars or to the end of the 4 cars, and keep these keep alive messages that they are active and running. And the minute we found that one of those 4 or the last car is not answering, we know that something happened. At that specific area, there are a lot of algorithms. I will not get into technical issues to confirm that it was really decoupled or was disconnected from the train set, and we provide a reliable alerts to the driver and to the control center with the embedded cellular modem that is already and also included in the device itself.
So, but at least one of the 4 cars in the back, one of them need obviously a device to communicate.
Sure. So without having any technology on those trains, we cannot predict that something happened. We cannot feel that, we need to have at least one of our device in the network connected with the locomotive, which is actually the gateway. It is the brain that creates the network.
Okay, and have you already a real-world application for the virtual digital? Is it like a project or is it already running somewhere or used somewhere?
No, it's already running. Actually, the first project was in Africa. Then we understood that we need to develop the second generation. So we did so. We just went with that to the market. We are already in few POC in Europe, in America, in our home base in Israel, and now we're exploring a new POCs. And for now, all of them with a great success. And the success is also lying on the fact that we know how to analyze information that is critical to the review of the wagon health status, and to transmit that back to the control center for additional analysis or for the alert.
but all the cases are they just normal rail cars, so there's not automatic coupling. They're just the standard European setup with the wagons, and then on top you put the sensors, the mesh communication. And how I can envision like the onboard unit on the locomotive, is this just an iPad which is there, or like something like that, or is this really integrated into the loco?
No, it's an integrated device that is fully certified with the railway requirements, and it continuously receives energy from the locomotive. It has installed constant antennas, which is very critical to have a reliable network. It receive and manage the network, everything automatically, and then it explode that information to the driver tablet or also to the control center through a satellite communication or a cellular.
Okay.
So even though if we are traveling cross-border in area that cellular is not, if it's not under cellular coverage, we know how to transmit the information about the entire composite status and the health condition of both the locomotive and the freight wagons.
Can you give us just a feeling like how much is an onboard unit roughly, and what are the investments in order to get to the status of the virtual digital coupling?
I don't want to get into figures because that could provide some wrong impression, because it's really depend about the sensors and the composite, the amount and so on. But I would say that it's not much expensive than any usual or standard telematic device that has today in the market for wagons.
Yeah.
On the locomotive,
That's the
in the locomotive
point,
perspective, yeah, it's very cheap. Very cheap in terms of based on the European price, it could be, I don't know, even half of the price that is usually been priced for a device or for a controller being installed in a locomotive. And again, there is always the opportunity or the option to extend that also to additional telematics information that can be provided from sensors or from the locomotive network.
Let's flip it around. Maybe the question was a wrong one. Let's put it that way. Like any investment is like a good investment or not a good investment in terms of what you get back. In your cases, your real world business applications, what are the advantages for the real undertaking or for your customer?
Based on our research and our experience, most of the benefits eventually goes around increasing the operation efficiency. And I will get to that into details in a minute. After that, it's maintenance cost, reducing maintenance costs, even there a huge gap between the benefits that can be gained from increasing revenue because of more efficient operation than reducing very minimum cost that are based on maintenance that was shift from schedule to mileage or condition based. And eventually that there is the safety that no one is interested to invest on that because anyone says that, okay, there would be one accident, I don't know, or there would be, I don't know, one rail car that we need to retrofit the wheels because someone forgot to handle or to free the handbrakes. So no one is really interested on investing in safety. But operation efficiency, this is the main goal. And in freight, not like the passengers, there are a lot of coordination needs to be done between different stakeholders. Those that are managing the loading and unloading, those that are managing the shunting yard, that pulling the rail cars outside from the shunting yard to the main line, the dispatcher that needs to have that information, and the account managers that receiving the orders from the end customers and need to synchronize everything with the schedule of the main line. Now, inside the main line, again, there is some racing about that. So by using our technology, we synchronize between those stakeholders by providing them immediate information about the status in each milestone in this process. And by doing so, we are also increasing the quality of service to the end customers And he received information that he never had before about what is the status of his shipping in terms of was it loaded, when it went out to the main line, whether there was unplanned stop inside the main line, what is the estimated time of arrival, and making sure that he didn't had any brutal impacts that could, for example, that could hurt its goods.
Okay, and basically an interesting point. Stakeholder, like for example, is like in Israel, for example, is the infrastructure manager also stakeholder? So they're really taking the data you are generating and using that for their system.
In that specific case, they are using our system in one of the ecosystem that they develop to manage shunting yards and the transportation of the freight. So we just provide that kind of information. In this specific case, again, it was very important for them that everything would be very accurate, near real time, up to the level of location precise. So they ask us to provide track level visibility, meaning that the system needs to be to provide a precise location in terms of centimeters.
This holistic approach is interesting, as I just know companies which are specialized on the more monitoring of the local, like Railnova, or the focus on the wagons. But I haven't seen an integrated system yet, and that's what you're doing, right?
Exactly. And once they know how to use the data, for example, to know the right order of the wagons, because not all of them belong to the same customer or need to be unloaded at the same place. And since everything been done manually, there are a lot of mistakes. So this is, for example, one of the benefits that they can use or in use.
Just to get a picture in the future, so let's assume that the digital automatic coupling will be implemented in Europe. Is there still a need for your solution, or is the DAC in the current state like really also solving all the topics what you're solving without the digital automatic coupling?
In general, the virtual digital automatic coupling that we invest with is only tactical. It's only tactical move to allow immediate information between the locomotive and the wagons. Most of our investments now goes to how to analyze using different sensors the condition of the train in terms of safety, operation, and maintenance. So for us, I would say that 80% of the investments we are doing now will also fit to the DAC in the future. When there will be the DAC, I think that 90% of what we develop, especially for the mesh connectivity, will not be necessary over there. But at any case, if you have even, I don't know, few wagons at the end that will not retrofit with the duct, they could be equipped with our device and they could provide a full overview about the condition of the trains. And I want to believe, I don't know, 2 years ago, the Europeans said that by the end of 2030, the DAC will be there and will be fully deployed. Now we're talking about 2040. The budget started with 6 to 10, then it jumped to 24 billion euro to equip the entire European fleet. So I'm not sure about the numbers and figures for today, but I really hope that it will go there. But I think that it will take time and they need immediate response from us, the suppliers of telematics and IoT, for the safety issues, for maintenance, for operation, to close the gaps between the demands for the growing requirements for freight transportation with technology.
I would even say you have a great experience in the ecosystem of rail, and you can see safety could be or is basically an efficiency driver. And if we talk about innovation, I mean, what you have a global experience, let's put it that way. What is your opinion? What is the biggest challenge in driving innovation in the rail sector? And let's put it really the global rail sector. What is your experience?
There are still a lot of regulation, homologation, some big words that sometimes just hold or stop us from adopting new technology. There are very limited financial investments. in innovation in this area. Unfortunately, maybe Europe is one of the leading in this area worldwide, but Europe, it's only 10% of the global. Also in terms of challenges, in Europe, for example, the length, it's very limited, and not comparing to what is happening in Australia, Brazil, US, and Africa. So without having those investments, without having the culture of thinking out of the box, and without the beliefs that the freight train is actually the key engine to any economical growth globally, all of those together just a little bit stop us as suppliers for telemetry from putting additional investments or to adapt technologies or to deploy technologies in the railway sector.
Who is the front runner in implementing new innovation in the rail system? Is there a specific country you say that's the country number one if you would like to see innovation go there?
I think that Europe is the leader one.
Okay.
I think that in general, I don't know, Germany and Switzerland are quite leading some of those new innovative program. Some economical environments now maybe stop us from getting into the innovation process as much as we wanted to feel. You know, I think that it was mentioned a lot recently in the different conferences and events. But I believe that once there will be a global recognition about the benefits from freight trains, more investments, and maybe even a young generation will have its own contribute, because it's very hard to think out of the box in this very closed market where everything it needs to be tied with a metal and maintained by schedule, by the OEM instructions. All of that together will help us to move forward.
Okay, perfect. And Trilogical is located in Israel. And can you just give us a brief intro about the railway sector and the railway in Israel? Because it's actually an island, right? Because like surround us, there's no really a connection to the other countries. So can you just give us a feeling about what the rail in Israel is all about?
Yeah, sure. Israel is growing. Israel is undergoing a rapid rail transformation with major efforts focused on electrification, deployment of ETCS Level 2, introduction to the new electric assets, including trucks from Alstom's, the locomotives, and Siemens new EMUs that just brought to the market and already fully deployed in Israel. There is also a development of digital control center and smart mobility integration. In addition to that, a new light rail system being introduced in the system. The last one is the Red Line in Tel Aviv that is fully operation for the last 2 years, and now currently we are under construction of new 4 lines, and the biggest project that will come in the next years will be the metro that will connect the entire control center.
Is it an open market, so liberalized one, or there's just one state-owned railway operating passenger and cargo?
The intercity, the railway itself, not going to the light rail, yeah, it's one operator. And is responsible for the infrastructure, for the assets, for the operation, for the maintenance, for everything. On the freight side, is also the only supplier of maintenance and operation, but there could be cases that he received the wagons from the end customers. But eventually, yeah, it's a monopoly, it's a governmental office that run the train 100% by itself.
What role will AI play in the future of rail?
I don't know. I'm using that at any minutes or seconds, even if I need to run thoughts or to comply to a letter or to write an email. And of course, whenever it comes to technical issues, the first guy I'm asking is, for example, it's ChatGPT. Today, we are using the AI mostly in the development. So any algorithm that we need to develop based on information and use cases, we're using the AI. Today we already upload more than, today it's 5 million sensors every hour, out of 30 millions that we filter, 30 million sensors every hour. So I'm quite sure that from predictive maintenance to autonomous operation and intelligent traffic management, the AI will have a significant, important role in the future of rail.
And beside like the ETCS and DAC, whatever, do you see any disruptive technology in the railway sector? Or what's the next big thing in your opinion?
First, it all will come into sensor fusions, developing new sensors, edge computing. Since not everything can be analyzed offshore over the cloud, putting AI that consume low energy, that know how to predict things based on information that it samples, for example, vibration, that we sample 1,000 sample every second, and you need to analyze that and to understand if there is a problem. And of course, the remote diagnostic itself, all of those are making the biggest waves, I think, now, especially from companies that can scale quickly and adapt those technologies and information.
And if we like connecting all our assets to the cloud and to get it online, we need also to talk about the topic about cybersecurity. So what is your take on this topic, and is it important?
Sure, it is. And as we mentioned, as a company that comes from a defense background, we put that at the front of us. At the first look, maybe someone would think that what could happen if there would be a location device on a freight wagon. What can go wrong? Why cyber is crucial? And the answer is very simple. We can take some very simple cases or example. Let's assume that we currently have 500,000 wagons equipped with our devices, sending information about their location, about operation, their status. And someone decide to duplicate all the information from from a week ago, let's say. There would be a chaos. Everyone that is currently depending on that information for their operation, for loading, for safety issues, how to catch the lines in the main line. Now they have information from a week ago, information that until now they were fully dependent on that, and all the investments that were put on wagons for years now become irrelevant. Now you do not have any option to close that kind of a risk, for example, in one shot, because you have no connection to the right, and what can you do? So maybe at that stage, the suppliers will decide to upload a new version. So the hacker will wait for that. He will learn how he can upload a software to the black box. And he will do the same, but this time he just will lock and block the device from operation. And again, all the investments, all the information, all the processes that were dependent on that very simple, stupid device on a body of a metal with 4 wheels now become useless, locked. And the only options for you to recover that is to have a technician going manually to all those devices and maybe trying now to do some encryption that could prevent that. If you have encryption on the device, data and information, then on the server side, you can ensure that you have a reliable information from now that was not duplicated easily by any hackers from outside. So that was a very simple one. But again, if you're working with Bluetooth or mesh connectivity, at any point of that, we can just at a single moment decide that we want to send a false alarm, or we want to send wrong information. Now the driver receives an alert that he needs to stop immediately because there is a derailment with the car. and I can send the same alerts to, I don't know, 100 trains working together at a specific day. Again, a chaos can be happen very easily. And because it's very simple system, and let's say less advanced than devices that are being used for the ETCS level 2 on the locomotives, it's much more easier to approach them and to make those failures. And if you're not being prepared in advance to those scenarios, you will not be able to respond as fast as you can for virus that can be easily detected on your computer because you do not have access to those devices.
Okay, because that's quite interesting. I was just thinking like what happens if you hack the loco, but I think it's not necessarily needed to hack the loco. You just need to send wrong alerts, and then you will have like a chaos in the system. And what is your like also experience on, as we said, there are a lot of companies having these devices and a lot of railway undertakings using these devices, but is there sufficient focus on this topic on cybersecurity, or is it at the moment, at the very beginning, and very naive to think this not going to happen?
The market is still very naive.
Okay. I was assuming.
No. First, there are no standards, and those standards are not really focused on the cybersecurity threats. And I think that it's better for the market to highlight that issue and to handle that and to include that as part of the technical requirement or specification, either for the standards and regulation and for the future suppliers of telematics for railway.
Okay, but I guess you're addressing the topic with your solutions, right?
Of course, sure. Again, I just must say that any of our devices that is using transmission over a cellular already have embedded cybersecurity models to ensure that none of those threats will happen in our area.
Okay, and as you mentioned it, but ETCS, this is like a safe system, or also not really?
It's a safe system. It's not a system that can be hacked, but there are different layers of protection. And the fact that it's a composition of onboard device and algorithm and a wireless connectivity that is very separated from the public access networks, all of that just bring a new barrier. But the ETCS level 2 is not only based on the information that comes from outside. Like the level 1, it can work independently. It has its own rules. So there are some layers and level of protection. I think that there is more to do in this area. There are some very interesting startups in Israel trying to deal with those challenges. But since it's a safety system, it's very difficult to integrate active systems. So they are mostly more passive. But yes, it's very easy. And if we will consider that most of the attacks happening from the inside, having an employee that's trying to do something that is not by the book, today it can do some of the operation that we don't want to have or to feel when we are using the train.
Me not, but have you already heard about like an hacker attack on, I don't, sensoric of wagons, for example?
No, I've not heard of that. I think that the market is not mature enough to have the interest of those hackers, but it will come once it will be crucial and significantly important to the economical and the operation, then it will catch their attention, and I'm sure we will get there. I hope so, that it will be interesting enough to hack and to attack, and we need to be prepared.
Very interesting topic. And then let's just look in, because one of my last questions is always like, how do you envision the railway industry in 2050? So another 25 years to go from today.
This is simple. Everyone is already talking about that. First of all, it will be fully connected, autonomous, with a carbon neutral rail network, seamlessly integrate into a broader mobility ecosystem, playing significantly higher role in the transportation across lands. I see the line from Africa to Asia to Europe in a very high speed passenger and freight trains, and I'm sure we will get there.
What is the contribution to drive climate change?
I think that to adopt the trend of shifting from trucks and moving to trains, freights will have its own contribution for that. I think that we are already in the way to do so, and we can go further by accelerating electrification to reduce the use of diesel, to invest in energy efficient technology and optimize operation through digital tools. And again, by shifting more to freight and passenger traffic from road to rail, that will improve overall network efficiency and significantly reduce the carbon emission and make it magnificent contribution to combating the climate change.
The ball is in your court. What is the next step to drive change?
The next step is to large-scale implementation, moving from pilots to real-world deployment. And that requires a strong collaboration between industry, stakeholders. We talk about investments. And to scale to proven innovation and create lasting impacts across the rail sector.
Which superhero do we need to avoid the climate disaster?
It's really hard to think on a single superhero. I think we need a team. We need a team of engineers, policymakers, innovators, and all of those that can push the digitalization and the future of transportation. And it will be, again, one single hero that can collaborate between all the industries, governments, to have aligned cross-border lines, and to have the investment and the new approach of digitalization to the rail sector.
Yeah, I think that's some really great closing words, Eyal. So thank you very much having you in my podcast in RAILUP. Thanks for the insights about your company, about your solutions, to get a spirit of the global innovations ongoing in the sector, and of course to speak about the very important topic of cybersecurity. So Eyal, thanks very much having you. Greetings to Israel, and welcome to the RAILUP Club.
Thank you very much, Sebastian, for having me. I really enjoyed the broadcast, and I really hope to meet you once again in one of the near conference in the way of digitalization and the future of railing.
What's the takeaway from this episode?
My key takeaway is that many new technologies in rail actually have often their roots in the defense and or aviation sectors. And that's a good thing. We don't need to reinvent the wheel when it comes to innovation. We also learned how crucial reliable connectivity and data are for the future of rail, and how the virtual digital coupling could offer faster and more cost-effective paths towards for DG train operations. What really stood out was how surprisingly easy it can be to hack a sensor-equipped wagon, highlighting that cybersecurity must play a much more prominent role in the rail industry. As Eyal put it, the railway of 2050 will be green, fast, connected and safe, and we explored what it will take to get there. And that's what RAILUP is all about.
This podcast connects innovators and leaders worldwide to shape the future ecosystem of rail. Rail Up by Sebastian Sperker.